are doing an experiment with me, and this is going to require money. So I have $5, and whoever gets the bet right gets the $5. Because I want you guys all interested in what we have to learn today. Okay, so here's the biggest thing. Each of you have a glass of water, and you're going to be getting an orange. Here's you, or a clementine, whatever you want to call it. Caleb? And Carson can catch. Good catch. Okay, so now this is a little, it's not really a science experiment, but we are going to make little predictions and hypotheses on what's going to happen when you put the orange into the glass. But before that, we're going to review a couple of things. Who knows what density is? Yes, Dad, what is density?
Density is the amount of mass that an object has.
Okay.
Wrong.
No, that's right. So density is the mass of an object relative to its volume.
To its volume.
Right. So what happens if an object with a lot of matter in a certain amount of volume, what kind of density does it have if it has a lot of matter?
A lot of matter. It's dense.
It's very dense. So it's
Very dense.
It's very high. It's very high density. Okay. Carson, what happens if an object with a small amount of water?
It doesn't have very much density.
It's less dense, right?
Yes.
Okay, awesome. So this is kind of our experiment today with these oranges in our cup. So here I have $5 on the line. So everyone, we're going to make predictions. Dad, Caleb, and Carson. And here's a pen. I'm going to grab pens for everybody. Now, what I want you guys to do on your predictions is write what you think about when the orange is peeled. Is it going to sink or float? Is it more dense or is it higher density? And when it's like still whole with the skin, the rind on it. Okay? And then I have Caleb, I'll get you a pen. And then we're going to put these up, and that's how we're going to know, we're going to kind of make our predictions, form our hypothesis, and kind of see what happens with our density of our orange or our clementine inside this water. Anybody have any ideas? I know you guys are still writing, but anybody have any ideas about how a boat stays afloat? This is kind of the same principle. Carson, you own a boat. Do you know how it stays afloat? Do you know how your boat stays afloat?
Yes, water displacement. It's more dense than the water is.
Right. Good. Wow. Okay, Carson.
I study.
You study. Okay, so what are you guys' predictions? I'm going to hang them up on the board so that nobody can change it. All right, Dad, you're probably right. You're right about everything.
Kiss up.
Carson. All right.
You know, one of us is not like the other.
All right, there's Carson's predictions and Caleb's predictions.
With skin, it will float. Without skin, it will sink.
Peeled, not peeled. We know who, oh jeez. We know who, studied up on their density before I came. Okay, so we talked about the objects with more density have a high density, right? Have a higher volume. Okay, so when you put your peeled orange into your unpeeled orange into the cup of water, will it sink or float?
I think it's something
Float.
All right, put it in.
Floated.
It's floating.
All
All
right.
right, so who wrote that?
We all did.
All three of you guys. Oh my gosh! I'm gonna have to rake out $15 now. All right, so now everyone peel your orange. Now, obviously, what's gonna happen when you peel your orange and put it into the water?
We think it gets less dense.
Therefore,
Just
sinks.
be careful with the scissors. It sinks, right? Oh.
It floats.
It's supposed to sink.
I think that the only reason that it is floating in this amount of water is because of the amount of air that is still within the orange.
So mine sinks.
Oh wait.
Yours is a hole in the middle of it. Does Carson's?
So mine still has air.
Yeah, so Carson didn't peel all his skin off, like on the ends, you know, like right there. Now let's see if it sinks or floats. What a good observation.
So I win.
That's not true.
Carson's still floating. He's wrong. I'm right.
Here. Okay, there it is.
It's starting to sink.
Alright, we have one piece of orange.
His son too. But Carson was floating.
Carson was definitely floating, and you said that's because you didn't take off the ends, right?
He did take out the ends and it's still floating.
Well, why do you guys think that is? Here, I'm gonna walk up and show our audience what happens with Carson's. Okay, Dad's is in one piece, Carson's is not in one piece. So there we have that. Okay, no, that's okay. So why do you think that the one? Why? Why is this
We
happening?
think because there was air inside of the orange that was trapped in that made it
It's like
Denser.
it's like when you breathe in your lungs.
reduces
explode.
the density. It created air.
Created
pockets.
air.
Due to the small amount of water.
Right. So it had air pockets which caused it to still float.
Right.
Without peeling the whole orange. Is that what you think?
That's what we think.
Cool. So what do you guys think that you can take away from this? I know we talked about the boats and things like that, but like what about density and volume and water? Do you guys have any questions about it?
So Carson doesn't get $5.
Right.
Carson
We
totally.
get $5.
Carson
So to
gets
clarify,
But
$50.
I think it has to do with the fact that the airtight seal of the peel both allowed it to the density to I'm sure it would be more dense versus allowing it to allow air out, and therefore the density of actually the material made it sink.
It's a great point, Mike. I think that I just want to clarify something.
Yeah.
When something is more dense than water, it's going to float, right?
Okay. Let's
When
talk about
it's
higher
less
density.
dense, it will sink.
Right. So the higher density of the orange with its
No,
peel
I just want to make sure.
keeps it afloat.
Right.
And then once it has
So what
lower
happens if I were to
density,
put the peel in the water?
It would float.
peel, yeah. No matter what you do, it's gonna float. Another thing that's really interesting about the peel versus the just the actual orange itself is the peel is more porous, and so what happens is it contains, bless you, it has air. Water down the orange is not good. It has air pockets like within the peel, within the rind. Where's your rind?
So that creates more.
Right. So it's creating that buoyancy.
It actually
Bounces.
undoes or bounces out the density.
It balances the density out. So regardless of the density of the orange, honestly, the rind is what's keeping it afloat. It's
Which is why his floated when
because-
the plugs were still in the ends.
yeah, it didn't matter because it was still plugged, and so the density was
Just
still
like a
there.
boat.
Because the air created the
Right.
the buoyancy.
Right.
Perfect.
So does anyone have any further questions about this? I think you guys did a really good job making predictions and forming a hypothesis on what you guys thought was going to happen with the oranges. And you guys were a really good class for me today.
Thank you.
Thank you.